We can definitely still ask questions. Okay, so today we're going to talk about domain and range from a graph, and we are going to review some vocab that you already know. Domain, range, relation, function, okay? One of the things in this class that I'm going to be pushing you on to help you get ready for your next class in pre-cal and then in calculus is your vocabulary, okay? I'm going to really push you to use mathematically accurate vocabulary, less than just the stuff you use to remember things. Okay? Obviously, we all have our own way we remember things, and that's great, but then we've got to transfer that into our good math vocabulary. Okay? So, anyone remember what a relation is? Okay? A relation is any set of points. Any set of points as ordered pairs x comma y. A function is a specific relation. What do we remember about functions? How do you tell something is a function?
Like you have like a number, like two specific numbers of.
No, not quite.
I'm trying.
Nope, good try. If you look at a graph and I ask you, is this graph a function? What are you checking for?
Does it have a slope?
That would be if it were a line, yeah. Remember, a function is where it passes that vertical line test, right?
Mm-hmm.
And every x has to match up to what?
Every
1y.
one.
Okay? In a function is a relation where every x corresponds with exactly 1y. You might have been used to saying where the x's don't repeat. Does that ring a bell? Okay? When you're looking at a list of ordered pairs, the x's don't repeat. What that means is that every x pairs with only one y. So that's the upper level vocabulary that we're going to be using. Every x pairs with exactly one y. So you look at that in a set of ordered pairs by matching up the x's with the y's. And then in a graph, remember the vertical line test, right? If you draw a vertical line and it's a function, and that vertical line only passes your graph once. Okay? All right, what do we know about domain? Yes, sir.
Isn't it the furthest point from x to the furthest point from y? I guess.
Good. It's all your x values. Very good at your x values, and it does always go from left to right. Your smallest x value to your biggest x value. Is your domain representative of your independent variables or your dependent variables? Independent. X is always independent. Domain is your independent variables. All right, so on the other hand, range is which values? Your y values. How do we write our range? Where do we go? From where to where? Is it top to bottom or bottom to top? Bottom to top. Good. These are dependent variables. So some of you might remember the little frog guy. I'm really bad at drawing frogs, but Dolar says ribbit. Or Dolar the robot, yep. Okay. Domain goes from left to right. Range goes from bottom to top. Okay. All right. So We're going to be practicing some different types of notation today for our domain and range. So let's go ahead and look at number 1. What type of graph is this? What do we call this? A parabola, good. A parabola comes from a quadratic function. Okay. This graph, could I draw this graph without picking up my pencil? Yeah, it would go on forever, right? But I could draw it without picking up my pencil. This graph is what I call a continuous graph. That's a vocabulary you definitely want to know. A continuous, yeah. A continuous graph or a continuous function means there's no break in the graph. Basically, the way I like to remember it is you could draw it without having to pick up your pencil. You don't have to jump. All right, so let's talk about the domain of this graph. Remember, domain means all the possible x values. So what's the domain of this graph? All real numbers. This graph never stops on the left or the right. Okay? So the way we could write that in inequality notation, remember inequality normally means less than and greater than, but we're not going to use infinities in our less than and greater than. So what you can say here is x is an element of, which is this weird curvy e, and then the symbol for our real numbers is your double-backed r, or your funky r. So the way you read that statement is x is an element of all real numbers.
So is it okay if we just write an E? Or is it supposed to be like...
Try and make it a little curvy. It's kind of like a C with a line through it. Yeah. Okay. What is the range of this graph? Okay. 1 is the bottom, right? And it's everything bigger than 1. So with an inequality sign, how can we write that? Okay. Is it great? Could it be equal to 1? Yeah. So we got to put that little line under there. That's the range, yep. Okay, interval notation, you should remember from Algebra 1 a little bit. We're going to refresh our memories on that. All right, interval notation is the stuff with the brackets and the parentheses, okay, and the comma in the middle. So to write all real numbers in interval notation, again, you're thinking from the leftmost number to the rightmost number. So the farthest left our domain can go, would you agree, is negative infinity? And the highest or the farthest right it can go is going to be what? Positive infinity. Okay. We can never reach infinity. Okay? So infinity always has a parentheses around it because you're never going to be able to actually reach infinity.
And the brackets are for when it's like a reachable number.
Brackets are like when it's like an equal to, like less than or equal to, greater than or equal to. So since we can't ever be equal to infinity, we can't have a bracket there. Okay, what about the range, you think? What's the bottommost number of the range?
1.
1. Can we hit 1?
It's like bracket 1, comma, infinity,
Perfect.
parenthesis.
Perfect. It's from 1 to infinity. 1 is the lowest, infinity is the highest, and we can equal 1. Okay. Roster notation means like when you list numbers out. Is there any way we can list every number in the domain or every number in the range? No. So we can't do roster with continuous data or with a continuous graph. And why did I say this graph was continuous? No break. I gotta draw out by keeping my pencil down. Okay. So look at this A right under your graph. This is function notation that we're gonna be practicing a lot this year. How do I read this? Good. F of 2, or the function value at 2. So what does that tell me to look for on my graph?
2.
2 where?
2, 0.
2 for x or 2 for y?
2 for
X. Good. When it's inside your parentheses, this is where x equals 2. And what you're looking for is what is the y value when x is 2. So on my graph, I go find 2 on my x-axis. And what's my y value when x is 2? 5. So f of 2 is equal to 5. That means if I were to plug 2 into that equation, I would get 5 out. Okay? All right. B says, for what function value of x does f of x equal to? This time, what did they give us? Good. This time they said, okay, y is 2. What does x equal? Let's see. So I find 2 on my y. Sorry, there it is. Okay, I agree with you, it equals 1. Does it equal anything else?
Man.
Negative 1. Good.
Oh.
Both of these have a y value of 2.
You just do like the plus
It's
and
the
the
negative.
negative.
Yes, you can.
Yeah, why?
So think about at a y value of 2, I hit the graph twice. I hit it here and here. Okay? All right, let's look at number 2. Would you say that this is continuous data? No. If I were to put this on a graph, what does it look like? Just points, right? Let's see, 5 points. Okay, so this data is what we call discrete. Discrete data is just a set of points. There's jumps, a lot of jumps in the points. There's no pieces that you can draw with your pencil.
So you would like connect it with lines?
Not when your information only gives you this data set. Okay, so what's nice is that I can't use inequality or interval notation with discrete because the numbers are just these isolated numbers. It's just these 5. I can't say it's everything between -4 and 12 because then I've included things that aren't in my data. Okay, so I can't use inequality and I can't use interval with discrete data. Can I use roster?
Yes.
Yeah, and roster really just means to do what? List it out. Okay, so to do roster notation, we're going to list it out. Couple rules you want to remember. You always list in increasing order. What does that mean? Good. Smallest to biggest, lowest to least to greatest. And you never want to repeat any values. So if 3 comes up twice in our range values, we'd only list it 1 time. Okay, we draw one of those curly brackets. Okay, so let's start. What's the lowest number of our domain? -4. It looks like it's in order for us, so that's nice. So we're going to go -4, 1, 7. Let's make sure 17.5 is bigger than 7. Yeah, it's about 8.5, right? Or not about 8.5, I shouldn't say that. It is 8.5. And 12. Okay, let's do our range. What's the smallest value in our range? Okay, so -2. Then what? 4. Then 7. Do I put 7 again?
No.
Nope, just 7 one time.
13.
Then 13. Okay, is this a function?
Yeah. No.
What was the definition of the function?
Every x corresponds to exactly one y.
Okay, which means every x value can only match with one y. So did -4 match with any values other than 7? No. Did 1 match with anything other than 13? How about 7? 17 halves and 12. So this is a function. It's okay that your range values repeat. Okay? Your y values can pair with different x's. Your x values cannot pair with different y's. Okay? So this is a function. I would make note of that. This is a function. It's okay that the y value is repeated. All right, let's look at number 3. Okay, would we call this graph discrete?
Yeah.
Is it just random points, none of them connected? No. Okay, would we call this graph continuous? No, why not? It doesn't matter that it ends here. That's okay. What does matter is this guy right here. What is this?
It's an open hollow circle.
Good.
Non-shaped.
Sorry, just a second.
Who does not have a picture ID, please report to the library to get your ID picture made and to receive your ID. Once again, any students who wish to receive their ID, please report to the library at this time.
Okay, so you're right. This is an open circle, which means the graph doesn't hit there, right? So I could draw this piece without picking up my pencil, right? So this piece is continuous, but then what do I have to do? I have to jump, right? Or take a gap. And then would you agree I could draw this whole piece without picking up my pencil? So when a graph is made up of continuous pieces, but it has a break, we call it discontinuous. And what that means is the graph is made up of continuous pieces, but it does have a break in it. You've got to jump over something. Okay, so let's talk about our domain. What can you tell us about our domain? Where do we start? Let's start there. Where does our domain start? The lowest number. Okay, what's the lowest x value we have? -6. It's okay, the numbers are really small. All right, so -6 is our lowest value. Can I have every x value above -6?
Wait, yes. There's an arrow. Circle.
All except what? 2. I can have every x value except this one that I have to jump over. Okay? So what I'm going to say is I'm going to say, okay, my x values can be greater than or equal to -6, except x cannot be 2. I think that's the easiest way to write this. Okay? Let's talk about what that means in interval notation. In interval notation, I'm going to write this in 2 pieces. Okay? What's the smallest x value? -6. And can my graph be equal to -6? Okay, so I'm going to put a bracket at -6. And then for this continuous piece, what do I go up to? I go up to 2. Is my graph ever equal to 2? No, so I put a parentheses around 2. Then, to demonstrate I'm taking a jump, I use a capital U, which stands for the word union. And it means I'm going to take this domain and this domain and union them together. I'm going to connect them. Okay, so now I'm looking at this piece right here. The smallest x value at that piece is again what? 2. But can I ever equal it? No. And I can go all the way up. I have an arrow, so I go all the way to infinity. Questions? Let's try the range. Range goes from bottom to top. Bottom to top. What's the bottommost value? -5. Okay, can I be equal to -5? Yes. Even though I have an open circle here, isn't my y value exactly -5 here? Okay, so I can be equal to -5, and I go all the way up to what? 7. So I could write that as -5 is less than or equal to which variable? Y. And then what would I have? Less than or equal to 7. Good. All right, can you try and turn that into interval notation, please? Feel free to talk to your neighbor and get some help. Try and turn that into interval notation. So range goes from bottom to top. So what's the bottommost number? -5. Is my graph ever equal to -5? Yes. So what goes around -5? Bracket. Okay, then I put a comma. And my graph goes up to what value? 7. Is my graph ever equal to 7? Yes. So I put a bracket. Questions on the interval notation? Interval notation is what we're going to use most often in here, okay? My opinion is if you can understand it with an inequality, you can turn it into an interval. So that's why we do that one first, okay? Can I use roster notation here? No. Why not? Good, it's not discrete.
We can only use that with this.
Correct. Okay, look at A. A says to find f of 2. So remind yourself what that means from our problem before. What does that mean for us? Okay, x equals 2. Find y. What happens at x equals 2? Yeah, there's a gap. There's a break. The graph doesn't exist there. That open circle means the graph does not exist at that point. So what we can say here is that f of 2 is an undefined value because the function, I can use DNE for does not exist at x equals 2. Absolutely, please do. Never using my abbreviations if it doesn't make sense to you. The function does not exist at x equals 2, and we know that from what in the graph? The open circle. Yes, if it said f of 3, then f of 3 is equal to -5. All right, look at B. For what values of x does f of x equal 1? Good. That means when y is 1, find x. So if I go up here where y is 1, x is -2. Okay, let's look at number 4. Very good. This graph is discontinuous. Why?
Maybe that the continuous data pieces, but it hasn't.
Very good. I love that. It's made up of continuous pieces, but they have a break. It is not discontinuous because it has a defined domain. Okay, that doesn't matter. It's just the piece that you see. Okay, so
Students, please follow this pre-production. At this time, we need all fresh.
okay, so this has a break, so this is discontinuous. So let's talk about the domain. The domain starts at what x value? -8, and goes to all the way up to 3. Do we skip anything in the middle of there? What do we skip? Okay, so let's see if we can write that out. You could write it as 2 pieces and just put an and in the middle. That's fine too. Okay, but I kind of like it this way. All right, so I'm going to go from -8 is what? What sign? Less than or equal to what variable? X, which is less than what? 3. Good. Except what? Good. So x cannot equal -5. The other way you could write this is -8 is less than or equal to x, which is less than -5, and -5 is less than x, which is less than 3. Either of those are 100% correct. I do not care which way you write it. Whichever way makes more sense in your head is fine by me. Okay, let's talk about the range. Thoughts? -3. Let's do inequality real quick, then we'll switch to bracket. -3 less than or equal to y less than. Very good, because both values at 1 have an open circle. Okay, can you turn that into interval notation, please?
Yes.
Both of them, yep. Raise your hand if you need help.
Are you gonna use blue? Corresponding with you.
I'll use whatever color you want. Well, with the extent of what I have as an option.
Yeah.
All right, good job, guys. So some of y'all kind of forgot that break, but we're practicing, so that's great. So tell me, Molly, I'm switching to pink. Is that okay? All right. So tell me what we're going to do for our domain. -8 with a bracket, up to -5 with a parentheses. Union, good. Very good. Okay, the range was a little more straightforward. What's that? Good. Can I do roster?
No.
All right, what is f of 2? F of 2 is 0. For what values of x does f of x equal negative 1? Good. So find negative 1 on your x. No, I have 2 minutes. All right, so you're right. Negative 7, negative 3, and 1. Yeah, hang on 1 second.
Yeah, but